Hi everyone. Today I'm gonna show you some deep learning object detection models, and we're gonna implement one of them. And I'll also show you how to implement any deep learning model from a pre-trained model. These are the pre-trained model. So every year, the machine learning and deep learning community comes up with very accurate object detection models, and the accuracy has been increasing day by day. And some of the most used deep learning model right now are FastRCNN, YOLO, which is you only look once, and single shot detector, which is also known as SSD. And each of them come up with different accuracy, different outputs, and different speed. Usually FastRCNN provides very high accuracy, but it's quite slow. On the other hand, SSD and YOLO provides really fast speed but relatively low accuracy. So the speed and accuracy not only depends what model we are using, it also depends what feature extractor the model is using. As you can see, the FastRCNN, it is using Inception ResNet version 2 feature extractor, and this FastRCNN using ResNet 101, and this is SSD is using a different feature extractor. Here you can see the SSD, their latency is really low, so they process the frame really fast, and sometimes their accuracy is a little lower than the other models. You can see the FastRCNN provides the highest accuracy, and in one case SSD is providing much higher accuracy than RFCNN. So because it's using a different feature extractor. For this lecture, we're gonna implement one model that's called MobileNet, SSD MobileNet, and we'll deploy that, and we'll try to find the result. So TensorFlow is the most common and widely used deep learning softwares. It was developed by Google and extensively used by Google. The TensorFlow community in Google provided a GitHub repository where they provided all the codes to train the model for the end user like us. And this is the GitHub repo. It's github.com TensorFlow model. It's around a couple of 100 megabytes, and it got a lot of branches. You can see a lot of versions. So for this lecture, we are gonna use 1.13.0 and these are the available models. These models are already trained on certain amount of objects, so some of them can identify 80 different type of objects. They includes human, cow, dog, car, a lot of stuff. So if you are using this TensorFlow model and you got a NVIDIA graphic card, like you have a gaming computer, then I strongly suggest you to use the GPU version of the softwares. It will be almost 100 times faster to train the model, so it makes your life easier. So for today's class, we are gonna use the Python 3.5 or Python 3.6. I think Python 3.6 will work, so this is recommended. And there are a couple of files in the TensorFlow let me show you. In the research object detection protobuf. So this is the protobuf file. This format was also developed by Google, and it keeps data structured so that anyone can reuse them and reconstruct the data later. So we have to convert this file into Python file. You can also convert them into JavaScript, PHP. So they're really versatile. So to do that, we have to have protobuf. So if you are using the file I'm gonna upload, the model file, you don't have to do anything. It will automatically run. I provided the protoc.exe file inside the research folder. In Linux, it usually comes automatically. If it doesn't come, then all you have to do run this line of command, then you're done. And we are using the model repository 1.13. I think it's 0, not 1, as this version. I'll also add this file in the class lecture note. And we're also gonna use a couple of softwares. So I know some of you already have existing environment which got couple of softwares from this list. Maybe you got Philo, Matplotlib, OpenCV, Python, and Pandas. So what so far we did, we tried to install each and every software. Pip install that, pip install that. So you have to write the same thing for 8 or 9 times. To save that, I created an requirement.txt file and put it inside the research folder. If you go down there, as you can see, requirement.txt, and this is the protoc.exe I mentioned here. The protoc will be provided. So all you have to do, you have to run one line of code and it will automatically go and install everything. So let's dive in. You can download the model folder in 2 different ways. You can download the class lectures, which will contain the model folder and all the edits I made already. And if you download it from TensorFlow GitHub repo, then you have to do git clone, then this thing. So it will be git clone TensorFlow model. Then you can go to cd to gits and cd to model. You'll change the directory to model folder and then check out that will revert to the previous version. Because this is not actually the current version. This is 2 years old version, I think. So we'll install the library. So before do that, I have to tell you something. For this tutorial, we are actually using this is TensorFlow. This is the CPU version. If you got a NVIDIA GPU, I think you can change it to TensorFlow GPU and save it and then run it. If you don't have GPU, then this is just fine. Or for a PC with GPU, the best could be just delete this line of code and run conda install TensorFlow GPU equal 1.13.1. It install all the necessary dependencies, so it will be much easier. So I made a new environment and I activated the environment. So you can just call Anaconda. Then this is the windows it will open, and you'll activate your environment. By activate, my environment name is MENV, so I just activated that. So the first thing you have to do, you have to go to the research folder. So this is the research folder. So I'm gonna to do that, I can just change the directory from here to go to that folder. but I can just also just go to that folder and click on the path and copy it and do cd. You have to put the comma, inverted comma on the both side of the path. And one of the thing I would like to recommend is to put the model folder in somewhere inside your C drive. It's in other drive. I don't think the Anaconda prompt can access that folder, so it's just in C drive. So I'm here. When you are inside the research folder, you have to run the following line of code: pip install r requirements.txt. So I'm gonna just copy. Oh, it's not. Just press enter. It will take some time. It will download the libraries and their dependencies. So it's done, and it took around 7 or 8 minutes, I think. So we installed all the libraries we need, and the next thing is to convert the protobuf file. So it says change the directory to research folder. I think I'm already inside the research folder. As you can see, it's a models/research folder, and from inside that folder I have to run this command for Windows. Okay, just copy the command. Here is the research folder, and here is the product.exe file. So the command prompt will use that file to convert the product file that's inside object inside that folder. So let's do that. We copied the command from the lecture notes from here, and all we just did, let's shift it to the right side, and press enter. So there is no error messages. That means the files are converted. So all the files are converted and it's ready to go. This is one of the annoying part in the whole TensorFlow model. You have to set the Python path each and every time. For Linux, it's just one line of code from the research folder, but for Python, it's a little bit of three. You can say three. So the main objective of this setting Python path is, for running the course, you add 3 default path to your Python path. So one will be the model folder, second one will be the research folder, and third one will be the object detection folder. So 3 folder. So all you have to do, you have to set Python, copy and paste that, and then path of the folder, a semicolon, path of the research folder, semicolon, path of the model folder. Please follow that. There is no inverted quotation mark here. You don't have to put that, just the path of the folder. So the path has been added. So you're ready to go. Now you can run the model. What we are gonna do, we are gonna run the Jupyter notebook. So to run that, just type Jupyter notebook, and just press enter, and a new window will be opened on your browser. It's more like the folders you can browse through that. I think some of you guys already familiar with this one. So I think it's research folder, and we have to browse object detection folder. And inside the object detection, you see the object detection tutorials.ipynb. This is the Python notebook file. I have edited that file, so there are some changes if you download it from the model directory, GitHub directory. So just click. So I made a couple of changes here. What these codes are doing is actually importing all the libraries it need. And the next thing is we are going to use the SSD mobile net. So this is the model. So it will download the folder automatically from this website, download tensorflow.org, and extract it. It will download that one, and it will load the TensorFlow model into memory. And once it's done, it will do some other stuff. And finally, this here, the last chunk of code, it takes images, whatever image you give, and it convert the image into a n by m array. Then it just flatten the array. That means it's more like a list. And the object detection model is run. The detection the model will provide the detection results. The detection results are detection boxes, and there are classes, and the scores. Scores mean the confidence rate. So it could be, the model could be 80% sure that's a cow, that's a dog. And the classes is maybe 5 equal cow. There are 80 class 1 equal maybe human, class 2 equal dog, class 3 equal cat, class 5 could be equal cow. And the detections will be provided in boxes. So you can run each and every cell individually, or you can run all. So we'll run each and every cell individually. So we'll select the cell, run cell. It will show some errors, but don't worry about that. The shortcut is Shift Enter. So we are using the shortcut, and here also I think it's downloading the model right now, so it will take some time. Let's see. Yeah, it's done. So the test image path is declared at test.images, so which will be research object detection. You see, this is the place. You can put whatever file you want right there, and it will run the detection model and save the output in the output folder. So we got 2 images. One is couple of 2 dogs, and another is some people, kite. That's it. Let's run the last chunk of code. It takes some time. As you can see, the detection confidence is 93%, and this one is 94%, and person, kite. So just go ahead and download couple more free Google images. This we get couple more images, so delete the result one. We're gonna run the, if you just put some new files, you don't have to run everything. You see, this is the past to test image. Just run this chunk. It actually takes the new images into account. If you don't do that, then it will just give you the output from the two previous images. So, and run the last time. It's taking a bit of time. Yeah, let's open that. Car, person, this guy wasn't identified. This guy was identified correctly, and there are a couple more false true positive detection of car. I think it's me missed some of the background due to the blur. Let's see. And this cow, they're perfectly identified. Next one, yeah, it's also quite good. So it's performing quite well. So all you have to do right now, you can put some of the images, 3 or 4 or 5, whatever you want, into that folder, the test.images folder, run the model, get the output images like that, and I'll try to create a quiz or the in-class exercise online, so you guys can upload it there. And the next thing is, so you already ran the model. Where is the model? Let me show you. So this is the model. So here there are a lot of models. So SSD MobileNet version 2, this its precision is I think 22%. So we'll go with a little bit better model. So this one says SSD ResNet 50, its precision is 35. So if you guys can use a completely new model for your own object detection, that will be really good for you. So I'm gonna use that. So all I have to do, I have to click it and it will start the download. It's 350 megabyte and compressed in tar.gz format. To unzip that format, you have to unzip it twice using 7-zip. If you are in Windows, I think in Linux, all you have to do, you have to just write on the terminal unzip and the file name, it's automatically unzipped. It's pretty straightforward in Linux. Yes. So this is the file. Just copy it and paste it into your object detection folder. Model research object detection in that folder. So we're gonna paste it. There it is. So let's unzip it. 7-zip. I'm using 7-zip. You can use other softwares too. So this is the folder. After unzip, you see it creates another zip file .tar. I'm gonna unzip that again. I'm gonna copy whatever files inside, actually cut whatever files inside, and paste it here. So this to this folder is empty, and this is the tar file. I'm gonna use them to save the space. For better use and simplicity, just rename it to something shorter. So SSD ResNet, you can just put whatever it is. I usually prefer to rename it into shorter name, SSD ResNet. Copy the name and go to your object detection folder. You see the model name, just replace the model name with SSD ResNet. And you're not actually going to download that file from internet, so just comment it out. You can just delete it, or you can just put a hash before the line. And you're not actually using the download model, so you can also comment out the whole thing. For comment out the whole thing, just control and the question mark sign key, and it's ready to go. So let's test image. So this is the output from the MobileNet. We're gonna just putting it inside the MobileNet folder. Just do cell run all. It will take a little bit of time, but it will run the SSD ResNet model and detect objects inside that 5 images and save it in the output folder. Let's see how it works. I think, yeah, it's actually trying to identifying the objects. Yeah, we got one. Yeah, you see in SSD the bus wasn't identified, this bus and this bus. I think this is use image. Yeah, so they are being identified quite good. I don't know why this guy isn't still identified. There are a couple more car identified than the previous one. Yeah, they are identified quite good. So the SSD ResNet, it can deal with much better with the small objects, I think. And it's a little bit of resource consuming than SSD MobileNet. Yeah, we got another one. Yeah, a lot of cows are identified properly. So you can do that, and you can choose whatever model you want and run your set of images and get the results and upload on the website. This is actually the in-class exercise, and on the other hand, you can train the model if you want. So in my research, I'm trying to identify steer in the farm environment when the lighting condition is really bad. So to do that, I have to train different models on my own data set, and for doing that, it's better to use GPU. Other than the training would have taken maybe months. So sometime the GPU takes 2 or 3 days to train the whole model. So if you want to train your own data set, like identifying the location of the meat in a scene or the quality of the meat, then you can contact me. I'll give you much more detailed information about training on your own data set. I provided two more references, this one, the GitHub one, and the pythonprogramming.net. They actually explained everything, but by the time we are doing this one, a lot of things have changed. So you might find it difficult to train the model. If you want to train the model, I'll be there to help you, so just contact me. And I have edited or created couple more files, as I told earlier. The object detection tutorial.ipynb, I edited in couple of places, and there is another file that's in utils folder. So I also edited this folder, just 2 lines actually, not a lot of things, and I put product.exe file and requirement.txt file. So this is the difference between the model GitHub repo and the folder I'm gonna providing. So just give it a try and let me know how it works for you.